In this video, we're going to look at partial fractions with distinct linear factors in the denominator. Here we have f of x is equal to p of x divided by q of x, where p of x, the numerator, and q of x, the denominator, are polynomials with no common factors, and degree of p of x is less than degree of q of x. Assume q of x, the denominator, can be factored as a product of distinct linear factors. The first step here is to factor the denominator q of x in the form a1x plus b1 times a2x plus b2 all the way up to anx plus bn. Step 2 is to apply partial fraction decomposition. So we will write p of x divided by q of x as a1 divided by a1x plus b1 plus a2 divided by a2x plus b2 all the way to an divided by anx plus bn. Step 3 is to clear out the fractions, to clear out the denominators by multiplying both sides of the above equation by q of x is equal to a1x plus b1 times a2x plus b2 all the way to anx plus bn. Step 4 is to solve for the coefficients a1, a2 all the way to an by equating powers of x or substituting special values of x that will solve the equation for a1, a2 all the way to an. And step 5 is to integrate. We integrate p of x divided by q of x with respect to x, and we will have one term for every linear factor. So we'll have a1 divided by a1x plus b1, a2 divided by a2x plus b2, all the way to an divided by anx plus bn. And as you can see, the integration will be fairly easy to do. All right, so let's integrate. We'll get integrating the first term, we'll get a1 times natural log of a1x plus b1 in absolute value divided by a1. And the reason for dividing by a1 has to do with reversing the chain rule or the U substitution method, with u is equal to a1x plus b1 and du is equal to a1 dx. Integrating the second term, we get a2 times log of a2x plus b2 all the way up to integrating the last term, we get an log of anx plus bn divided by an, and let's not forget to divide by a2 here because of the U substitution technique, plus c. So basically what we're doing in all of these integrations is we have integral of this pattern 1 over ax plus b dx. And this integral will be log of absolute value of ax plus b divided by a plus c. So what we're doing is we're letting u be equal to ax plus b du is equal to a dx, differentiating both sides, and we solve for dx, we get dx is equal to du over a. The reason we divide by a is precisely the same reason we have a here. All right, so in this example, we're going to integrate 3x squared plus 13x minus 2 divided by 2x minus 1 times x plus 1 times x plus 3, integrated with respect to x. The first thing you will notice is that the degree of the numerator is 2, because the numerator, the leading term, is 3x squared, and that's power 2. The denominator, if you were to multiply 2x minus 1 times x plus 1 times x plus 3, the leading term would be 2x cubed. That means the degree of the denominator is 3. So the degree of numerator is less than degree of denominator. That means we can apply partial fraction decomposition. So we have 3x squared plus 13x minus 2 divided by 2x minus 1 times x plus 1 times x plus 3. We will apply partial fraction decomposition, and we will have a coefficient divided by the linear factor. So we have a divided by 2x minus 1. For every linear factor, we're going to have a term. The first term is a over 2x minus 1 plus b divided by x plus 1 plus c divided by x plus 3. The third step is to multiply both sides by 2x minus 1 times x plus 1 times x plus 3 to clear out the fractions, to clear out the denominator. So multiplying on the left-hand side, we will get 3x squared plus 13x minus 2 is equal to a times x plus 1 times x plus 3 plus b times 2x minus 1 times x plus 3 plus c times 2x minus 1 times x plus 1. Alright, step 4 is to substitute special values of x to solve for a, b, and c. So what we have is 3x squared plus 13x minus 2 is equal to a times x plus 1 times x plus 3 plus b times 2x minus 1 times x plus 3 plus c times 2x minus 1 times x plus 1. We have cleared out the fractions. Our job now is to solve for a, b, and c. So we're going to plug in x equals negative 1. Why do we plug x equals minus 1? Why do we choose this number? The reason is because it makes the first term become 0, it makes the third term become 0, and that enables us to solve for b. Alright, let's do that. So we plug in x equals minus 1, we will get 3 times negative 1 squared plus 13 times minus 1 is minus 13 minus 2 is equal to, plugging negative 1 into the first term, we get a times 0, negative 1 plus 3, that's 2, plus b times, plugging negative 1 in, we get minus 3, times minus 1 plus 3, that's 2, plus c times minus 3, times minus 1 plus 1, that's 0. So the left-hand side works out to 3 minus 13, that's minus 10, minus 2, that is minus 12, is equal to 0 minus 6b plus 0. And we get negative 12 is equal to minus 6b. Divide both sides by minus 6. Divide by minus 6. Minus 6 cancels, and we get b is equal to 2. Now let's plug in x equals negative 3. So we get 3 times minus 3 squared is 9. Plus 13 times minus 3 is minus 39. Minus 2 is equal to, and we're going to get a times, we'll get a times minus 3 plus 1 is minus 2. Minus 3 plus 3, that's 0. Plus b times minus 6 minus 1 minus 7. Minus 3 plus 3, that's 0. Plus c times, we get minus 7 times minus 3 plus 1 is minus 2. On the left-hand side, we will get, we'll get 3 times 9, which is 27. Actually, we get 3 times 9, that's 27, minus 39, minus 2. And the left-hand side works out to minus 14 is equal to 0 plus 0 plus minus 7 times minus 2, that's 14, so we get 14c. We get 14c equals to minus 14. Divide by 14 both sides, divide by 14, and we get c is equal to minus 1. Lastly, let's substitute x equals 1/2 into both sides of the equation, and we will solve for the remaining coefficient a. Putting 1/2 into the left-hand side, we get 3/4 plus 13 over 2 minus 2 is equal to a times 1/2 plus 1, that's 3/2. Times 1/2 plus 3, that's 3.5, that's 7 over 2. Plus b times, putting 1/2 in, 2 times 1/2 is 1 minus 1, that's 0. Times 1/2 plus 3, that's 3.5, that's 7 over 2. Plus c times, 2 times 1/2 minus 1, that's 0 again. Times 1/2 plus 1, that's 3/2. So for the left-hand side, if we add up those fractions, it works out to 21 over 4. And on the right-hand side, we will get a times 3 times 7, that's 21, divided by 4. And then we're just adding zeros, plus 0, plus 0. So what we get is 21 over 4 times a is equal to 21 over 4. And dividing both sides by 21 over 4, we will get a is equal to 1. And the last step is to integrate. This will be the easiest step because we have all the factors, all the integrals separated out, and we can just integrate term by term. So we have integral 3x squared plus 13x minus 2 divided by 2x minus 1 times x plus 1 times x plus 3 dx, and we applied partial fraction decomposition, and we have integral of 1 over 2x minus 1 plus 2 over x plus 1 plus minus 1 over x plus 3 integrated with respect to x. So integrating the first term, what do we get? So what we have is equal to, integral of the first term would be log of 2x minus 1 divided by 2. And that's because of the U substitution technique, we're letting u equals 2x minus 1. Integrating the second term, we get 2 log of 2 ln of x plus 1 minus, integrating the third term, we get log of x plus 3, all in absolute value, plus c. This is the answer. All right, thanks.